Good morning. Our today's topic is polar form of complex numbers. You know that complex numbers represented as z, okay, is the sum of the real part and the imaginary part. Here in z1, the real part is 1 and the complex part is again 1. In z2, the real part is 1 and the complex number, which is served as a coefficient of I, is root 3. Now here, we are supposed to write the polar forms of Z1 and Z2. Let's see how we write. So, the polar form of Z1, 1 plus I, is represented as R into cosine of theta 1 plus I times sine of theta 2. And R is said to be the modulus of Z, which is equal to the square root of the real part plus the square, under square root the sum of the square of the real part plus the square of the imaginary part. In our case, the real part is 1, and again the imaginary part is 1, so R1 is square root of 2. What about theta? Now theta is the angle, okay, which we call the argument. This is the tan inverse of y over x, the tan inverse of the imaginary part divided by the real part. Now here in our case, this is tan inverse, the imaginary part is 1, okay, divided by the real part is 1. This is equal to tan inverse 1. This is equal to, okay, tan inverse 1, and this is equal to tan inverse 1, okay, is equal to 45 degree, which is pi over 4, 180 divided by 4. So using all this information, okay, we can write the polar form of Z1. Okay, Z1 is equal to R is square root of 2 times cosine of theta 1 is pi over 4 plus, okay, I times sine of pi over 4 is the polar form of Z1. The polar form of Z1. In the same way, the polar form of Z2, okay, the polar form of Z2 is equal to, well, Z2 is equal to 1 plus square root of 3 times I. Then R is equal to the square of the real part, 1 square, plus square of the imaginary part, square root of 3 squared. This is equal to square root of 1 plus 3, which is equal to square root of 4. Then this is 2. Okay, this is 2. And the angle theta, okay, this is R2, the angle theta 2 is equal to tan inverse of y over x. Tan inverse of y over x. Now our imaginary part is square root of 3, so this is tan inverse of square root of 3 divided by 1. Square root of 3 divided by 1. So the angle is 60 degree, okay, 60 degree. This is equal to 60 degree, which is equal to pi over 3. Pi over 3. Okay, so the polar form of Z2, okay, polar form of Z2 is equal to our R is 2, okay, 2 times cosine of theta 2 is pi over 3 plus I times sine of pi over 3. Okay, this is a polar form of Z2, the polar form of Z2. Once we find the polar forms, okay, how can we find the product of the two complex numbers? How can we find the ratios, okay, the ratios of the two complex numbers? Let's see on the other part. Now, Z1 is equal to square root of 2 times cosine of pi over 3 plus I times sine of pi over 4, and Z2 is equal to 2 times cosine of pi over 3 plus I times pi over 3. Then now here Z1 times Z2, okay, the product Z1 times Z2 is equal to R1 times R2 into cosine of theta 1 plus theta 2 plus I times sine of theta 1 plus theta 2. Okay. This is the product of two complex numbers in polar form. In our case, Z1 and Z2 are written in polar form. So now Z1 times Z2, okay? Z1 times Z2 is equal to, our R1 is square root of 2 and R2 is 2, so that the product of the two is 2 square root of 2 into. Now cosine of theta 1 is this, pi over 4, plus theta 2 is pi over 3, okay? Plus I times sine of, again theta 1 is pi over 4, plus pi over 3, okay? This is the product of the two. The product of the two complex numbers in polar form. Good. What is pi over 4 plus pi over 3? Now the common here is 12, okay? 12 divided by 4 is 3, then 3 pi plus this is 3, okay? Then 4 pi. This is equal to 7 over 12 pi. This implies Z1 times Z2, okay? Z1 times Z2 is equal to 2 times square root of R2 times cosine of the sum, 7 over 12 pi, okay? 7 over 12 pi plus I times sine of 7 over 12 pi. This is the product of the two. The product of the two. Well, now part C is to find the ratio of, or the division, okay, the quotient of Z1 and Z2 and Z2 to Z1 in polar form. Again, in polar form, when we meet division, okay, division of complex numbers, we simply take the ratio of, okay, the ratio of the respective modulus or r's, and the difference between the arguments. In our case, okay. Now Z1 over Z2 is equal to R1 over R2 times cosine of theta 1 minus theta 2, because Z1 appears first, okay, plus I times sine of theta 1 minus theta 2, theta 1 minus theta 2. So for this case, R1 is square root of 2 divided by 2 into cosine of theta 1 is pi over 4, okay, pi over 4 minus pi over 3, okay, plus I times sine of pi over 4 minus pi over 3, okay, minus pi over 3. So pi over 4 minus pi over 3. Now pi over 4 minus pi over 3, again it's still 12, okay, this is 3 pi minus this is 4 pi, so this is going to be negative pi over 12, negative pi over 12. So this is equal to now Z1 over Z2 is equal to square root of 2 over 2 into cosine of negative pi over 12 plus I times sine of negative pi over 12. This is the result of the division of Z1 and Z2. What if we have Z2 and Z1, okay? Z2 divided by Z1. Try that. There is a point of rationalization because Z2 to Z1 is, okay? Now here the modulus is 2 divided by root 2, so that you have to rationalize that to find the last answer. Now do not forget to subscribe at AHATube, okay? At AHATube 24. Your partner in academics and engineering and other courses. Thank you for watching. See you in the other topics.